Hey there, welcome back. Why don't you grab something to drink and let's talk about adding and subtracting rational numbers. So remember, rational numbers are fractions, right? So we're going to be adding and subtracting fractions. These fractions are going to have variable expressions with them. So we have to learn how to find the least common multiple of a variable expression. How does that translate into the least common denominator? And then we're going to work on adding and subtracting those rational expressions. So let's get started with the least common multiple. All right, so what we do, the big picture is you're creating a factor that contains several unique factors which are all raised to their highest appearing exponent. Okay, so the first thing that you have to do is you have to factor both of the expressions that you are trying to find the least common multiple of. So you have to factor them, and then you're going to pull out each unique factor raised to its highest exponent, and then you're going to multiply them together. All right, so let's start by factoring the trinomials here. Okay, so this becomes x plus 1 times x plus 1. So that's x plus 1 squared. Okay, and then we still have the 12x squared y and the 18xy cubed. This trinomial over here is x plus 4, x plus 1, and so we can't they're not the same, so we can't raise them to a power, so we're just going to write them down on the same line so our eyes are comparing on the same level. All right, now with numerals like the 12 and the 18, you could prime factor those and then pull out each unique factor raised to its highest appearing exponent. I find an easier way is to just kind of start thinking of multiples of the highest number. So I noticed that 12, ooh, didn't mean to erase. 12 does not go evenly into 18. So now I start thinking of multiples of 18. So that's 36, and 12 does go into 36, so I'm going to write down a 36. Now I have a factor of x. I have an x squared here and an x to the first here. What's my highest appearing exponent? 2. Then I'm going to have a factor of y. I have y to the first here, and then I have y cubed here. What's my highest appearing exponent? Y cubed. Then I have the factor x plus 1, and it's here and here. This is squared. This is to the first. So I have x plus 1 squared. It's to the highest appearing exponent. And then I have an x plus 4. And you just found the least common multiple. The least common multiple. All right? Let's try another one. All right, we're going to find the least common multiple between 2x plus 4 and x squared minus x minus 6. So the first thing we want to do is factor. So this is 2 times x plus 2, and this is x minus 3, x plus 2. Okay, now I want to look for every unique factor. Okay, so I have 2, and it's just to the first because I don't have any other exponent. Then I have an x plus 2 to the first and an x plus 2 to the first, so it's just x plus 2. If these x plus 2's had been in the same expression, then we would have had a squared situation, but this is to the first and this is to the first. So our highest appearing exponent is just to the first. And then I have this unique factor of x minus 3. So why don't you try the video question and then come on back, and if you got it wrong, make sure that you write it down so that we can discuss it and see what happened. All right. Hopefully that went well for you. Now we're going to transition into the least common denominator. So pretty much in a nutshell, the least common denominator is simply the least common multiple, what we just found on the last two slides, of the terms in, or the factors in the denominator. So you want to make sure you factor each denominator. So this is x squared, oh, sorry, we're factoring. This is x plus 1 times x plus 1. And this is x plus 4 times x plus 5. Okay. And now we have to select each unique factor raised to its highest exponent. So this is a double factor here, so I'm going to write it as squared. Okay. And this is a plus 1. Sorry about that. Just thinking adds to 5. Okay, so I have an x plus 1. I know for sure that's a unique factor. This one is squared, and this one is to the first. So I'm going to use my highest appearing exponent. That's 2. Then my other factor is x plus 4. So I'm going to add x plus 4. Okay, that's my least common denominator. Simply because it's the least common multiple of the things in the denominator. It's that simple. Okay. So why don't we work on this next one? We're going to find the least common denominator. Look at there. Denominator of 3 over 2x plus 4 and x plus 2 over x squared minus 6 minus x. So I'm going to factor first. So this just becomes 2 times x plus 2. This becomes x minus 3 times x plus 2. Okay, we're not canceling anything yet. Okay, so now what we're going to do is we're going to find the least common denominator. I have to have every unique factor showing raised to its highest appearing exponent. When there is no exponent, it's all just ones, right? So I need the factor of 2. 2 is a factor. Then I need an x plus 1. This is to the first and this is to the first, so I just need it to the first. And then I need an x minus 3. And that's our least common denominator. So why don't you try the video question? If you don't get it, answer it correctly, then what I want you to do is write down what you did on your notes, and then we can talk about it when I come around and chat with you tomorrow, okay? Now what we're going to do is we're actually going to add and subtract rational expressions. We're going to start with something that's super easy, and they're going to have a common denominator. So in that case, we already have the least common denominator. It is whatever that is. So adding is like super easy. You just choose that common denominator, okay? And then you add your numerators together. So that would just be 8, okay? For subtracting, it's very similar. You have that common denominator, but now what you have to do is you have to subtract off every single term of that second expression. So my first expression stays exactly as is. That's a common theme. And then minus 2x and then minus 11. Okay? Oh, I haven't been stating the domain. Let me get that in just a second. All right, so this becomes 3x minus 2x is x. 5 minus 11 is minus 6 over x minus 7. All right? And so what we would say is we could plug in any x as long as x does not equal 7 and close that off. Up here, we could plug in any x as long as x does not equal negative 2. Remember, it's whatever would make this denominator equal to 0. We have to kick that out. To the curb with you. Okay? Why don't you try the video question here and then come on back. If you get it wrong, make sure you write down what you did so we can figure out what happened. All right, now when we are going to add and subtract with different denominators, we have to find the common denominator. So the first thing you want to do is you want to factor it. These are all monomials, so factoring isn't as essential as like if we had binomials or trinomials, then it's essential. Here, what I do is I'm going to find my least common denominator. So does 2 go evenly into 8? Okay, then yes, so then 8 is part of my least common denominator, not 2, because I can't divide 8 into 2 and get an integer. I have to divide the 2 into the 8. And then I have an x, and it has to be my highest appearing exponent. And then I have a y squared, and it has to be to my highest appearing exponent. Now what I'm going to do, and I'm going to try and squeeze this in so you can see the thought going across my page like this, okay? So I'm going to try and write this kind of small. I'm going to take these original expressions, 2x cubed in my denominator here, minus 5z over 8xy squared. All right, and now I'm going to convert them to the same denominator of 8x cubed y squared. So the idea is, what do I have to multiply this first denominator by so that it matches 8x cubed y squared, okay? So I have my 3y, that's in my numerator already. And then I'm going to have 2 times what is 8? 4. And then I have an x cubed and an x cubed. I don't need any more x cubes. I don't have any y's over here, so I need y squared. Okay, and now I'm going to take my original numerator, and I have to multiply. I have to ask myself, what do I need to multiply 8xy squared by so that I get to 8x cubed y squared? All right, so 8 and 8, I don't need to change, I don't need to multiply 8 by anything, that's just 8. The x, I need to multiply it by an x squared. And the y squared, I already have a y squared, so I don't have to multiply that by anything. So my numerator becomes 12y cubed minus 5. I'm just going to do this in alphabetical order. X squared z all over 8x cubed y squared. Now state the domain. You can do this in the beginning or the end. You just have to make sure that you capture every term or every factor. So notice that I have both an x and a y. So neither one of those can become 0. So we can plug in anything, all xy's, such that x cannot equal 0 and y cannot equal 0. Okay. All right. Go back. I want you to go ahead and try the video question on this one. All right, now we're going to add with different denominators. We just subtracted, all right? So now we have some trinomials, so we're going to have to factor those denominators. The first one is okay. It can stay as x minus 1. This trinomial is going to be x minus 2 times x minus 1. So now what is my least common denominator? Well, it's going to be x minus 1 times x minus 2, and I'm going to convert these two fractions to have this denominator, okay? So let me try and write this. So I have x over x minus 1 plus 2x minus 1 over x minus 2 times x minus 1, and then my common denominator is x minus 1, x minus 2. Okay, so let's look at this first one. What do I have to multiply x minus 1 by to get x minus 1 times x minus 2? I need this x minus 2, right? I need this. So I have to multiply my numerator by that. So I have x times x minus 2 plus 2x minus 1 minus 1 And now look, this denominator has an x minus 2, so does this one, so I don't need to worry about that. It has an x minus 1, so does this one. So I don't need to multiply this numerator by anything. It already has the least common denominator. So now I'm just going to distribute and then simplify my numerator. So I have x squared minus 2x plus 2x minus 1 over x minus 1, x minus 2. Okay? So this becomes x squared minus 1 over this denominator, because these cancel. Okay? And now I can factor this numerator. I'm not done simplifying yet. So I get x plus 1 over x minus 1. And then, I'm sorry, x plus 1 times x minus 1 over x minus 1, x minus 2. And now I'm going to cancel. So now I get x plus 1 over x minus 2. Okay, now I have to state my domain. So go back to your original and make sure that you pick up every exclusion from the beginning expression. So it's all x's such that x cannot equal positive 1. Remember, it's the opposite of this, positive 1 or positive 2. X cannot equal 1 or 2. Okay, why don't you try the video question, and then if you get it wrong, then write it down and make sure you talk to me about it in the morning or in our class. All right, I'm going to save this one for our class time so that I can have something to refresh and review with. Thanks so much for listening, and I will see you tomorrow.